So yeah, my name is Piotr Witek, and yeah, I will be talking about building real-world application with static typing today. Okay, let me just start. Okay. So yeah, just wanted to quickly make an introduction. Like, I have a Twitter account, GitHub. You can check it if you want. And I'm working for the company called Meg. It's a software development agency which is in USA. We are making some cross-platform mobile and web application, working for the clients in the health, big data, stuff like that. Okay, so let's get into it. So I gonna maybe let me show you the presentation. Oh, something. Okay, so let me show you the application that I will be building, so you can see how it looks. So we're gonna build this demo application. We have some listing with the with articles. Okay, something. So we can create articles. Delete them. Oh, this is made for the purpose to show you the handling of the errors. So I make some kind of math random, and yeah, and you can view the articles. So yeah, so I'm going to start with the empty React app. It's only like we have only like app and home screen. That's basically it. So how I would start to build the application. Build the application is create a folder called features, and I will start like modeling the domain object that I will like to work with. So for that I create like types definition, and here I declare module, which I call my models, and I will explain in a bit why I do that. And I create an object that I will be working with, so it will be an article. Type. And we'll have some properties here. So I have like ID, maybe a title.
Can you make this background or another highlighting?
Okay, sure. Yeah, of course. Let me just do that. What is the theme? Yeah, thanks. Color theme. What's this? Okay. Sorry for that. Okay, so do you want me to make it larger like that? Okay. So yeah, continuing. We have a title, ID, and I add the content. It will be very simple object for the purpose of the stock. So now maybe let me explain why I declare this module. So basically, how that works is that where now wherever I want in my application use this type, I don't need to import it, which is kind of unwieldy with time. I don't like it. I prefer. I still can import it, but I can now use the global name, like a module. So I will use my models, and it will work. So it's simple than using, for example, relative path or absolute path. I prefer this approach. And also one more interesting thing is you can like extend this definition like from different locations. So you don't need to do that like in one file. You can, if we have like few folders, feature folders. So I will create the articles feature, and I would create another one like todos. So then I can, this should be here. And now I can create the same thing for todos. Let's create the todo.
This feature of web part, TypeScript compiler?
It's a feature of TypeScript. It's how the it's called declaration merging.
So is that like filename.t.ts or just
Sorry?
So the filename should be types.t.ts or just whatever .t.ts?
I don't hear you. Sorry.
What should be the file name?
The file name. Yeah, it's basically work with every file name that's working with TypeScript. So ts or tsx, and it should work. I like to do it in DTS because I don't want to include any kind of runtime. Like it don't allow you to implement anything, right? So it's good like constraint for me. So nobody else that work with me don't come here and implement something else except types. I like to keep only types here. Yeah, exactly. It's basically if you keep it in the source, it always like scan this file and build this definition. It's working similarly like with interfaces, right? So you can also like merge interfaces or namespaces together between modules with this syntax. So you can do like, you could declare also interface. And then add some property here.
By the way, why did you choose type instead of interface?
Okay, so I prefer to. Yeah, but that's actually an interesting question. So I would like to answer that. So basically, I like to use types because it shows me whenever, like, let me show you here. So whenever I hover over over this, when I use it, if I hover over this, what else? No. Okay. Yeah. Sorry, I missed that. Because it's already here. Okay. Oh, here. So whenever I hover over it in IDE, I can see the contents of this object. And if I declare interface, I will not see it. And I like to. It's just convenience for me. To have this option so I don't need to open this, go there and check like what properties, what shape it had. I can just hover over it and that's it. Okay, so that's for the question. Let's continue because we don't have like too much time. Yeah, so I have these types. I don't need that. I deleted. I have this type ready here. So what I will do next.
Can I just have a question? So you are always
Later, okay? So yeah, sorry. I need to continue because I have a lot of things to cover. There will be time at the end, so you will have opportunity to ask questions. Don't worry. Okay, so let's continue with the. So next step is I have this object that I will be fetching from the API. So it's probably somewhere in the database stored these entities. And I want to first create an API client. It's basically a module which will encapsulate operation to communicate with the API. So to do that, I will create a new folder. Services, and I will create a new file. Let me check here how it's called. Okay, so it's articles API client. Articles API client. And this file is, I don't know, I will just copy the contents because it just doesn't make sense to write it. And I will explain you what happens here. Okay, this is not in it for now.
You can name it just TS.
Sorry?
So it's like TS instead of TS, right? It's like API file.
Ah, yeah, that's right. It should be TS, yeah. Yeah, basically you should call them all TSX, and it wouldn't matter. But yeah, I prefer it also to keep it like this. And yeah, so we have a bunch of functions here. So basically, they are. I have a stubs setup here. So instead of communicating with some API, we'll have like set time and return the value of the variable here. That will keep articles that we create in the application, and it will load the initial state from local storage. So we have like load articles, create article, update article, and delete article. So all of that will, and here in delete article specifically, I have set up the error happening at random, so we can see how to handle errors in our React application. So to make it work, I also need to add local storage service. So local storage service is basically also encapsulation of the of two function, which is get and set, and basically you can save something in local storage. Okay, so I will just copy this file. Okay, we have it here. So here, nothing special about it. It's just doing some checks so we don't have runtime errors, and just saving data in the local storage. Okay. So now, with this setup, the next thing would be to start implementing store, application store. So to do that, let's copy the setup of the. Okay, let's copy it all. So it's basically a basic setup of the of Redux. It's using the most recent version with connected React router. The interesting thing here is I will show you in a moment. Is the setup for the router, which is using some helper get path, which uses some fancy typing to actually help you get the correct path with parameters. Okay, so here's also like nothing special to share with you. Let's continue with the store setup. Here will be much more interesting stuff. Okay, so I create a folder store. And here we can find several different files. So the first one I like to start with is root reducer. It's typical. I set up router and articles reducer here, which is not yet implemented. So let's comment it. Then we have types, and this is the most interesting thing. So how I also use the same module trick. So I declare module with another module, which is now called my types, and here I will keep a few different things. First one is root state, which is basically the state of the root reducer. I'm using some helper types from typesafe-action library, and I'm importing the default import from root reducer. Did I show you? And here, this root reducer is actually a higher order function, and because of that, because we want to instantiate the connected router, so we have to wrap it in the function. And here I use the return type to actually get the return type of that higher order function, and then I can get the state type, which if you hover right now, giving me router state, which is coming from the router definitions, React router definitions. Next thing is root action. This is something that will be implemented soon. It's basically how that works is I create a file root action and I import all the action files from my feature folders. Right now there is none, so I will create one. Equals actions. Okay. And this module have different. So I basically create this map object that maps names to feature folders. So here I have router actions, which is imported from React router, and article actions, which is from the article features. And all of them will create a root action type automatically, then I can import this type whenever I like in my applications. So I can use it in connected components. I can use this type in selectors. I can use this type in epics. And whenever I add new feature and add it here, it will automatically update itself. I don't need to add any additional types for that. So it's super easy to maintain. So let's try to add some actions to application. So here I will grab article actions. And let me explain what's going on here. So I'm using create async action helper from typesafe-action library. What it gives me, it creates a like a object that have 3 methods, which is 3 action creators with these types, and also with this types definition that I add here. So if I try to use it, and for example, I have request, success, and failure. So request is an action that I run whenever I want to launch a request to the API. And this one has undefined. So in this case, I just don't need to pass any parameters. And what it also changes is that when I declare undefined, it will accept only 0 parameters. So if I want to pass any parameters, it will show error because it's expected 0 parameters. Whenever I change it to strings, it will update and it will then show error whenever I don't pass any parameters or pass invalid parameter. So
it's not the return type of these actions, it's just like type of the input parameter.
Wait a second, I will show you. So so now let's change it to undefined. So now, if you hover over the action, it will show you empty action load articles request, and this empty action is just alias. You can see it here. So empty action is just an action with type and nothing else. If I change it to string and I add here some value, then we have payload action, which is load articles request type and a string payload. You can also check this one in the library definition, and it has type and payload. So what is cool about it is that you always, in your application, whenever you use it, you only see the properties that are actually on the object, like nothing less, nothing more. So you don't make mistakes, like and you don't need to check like for existence of the of some properties. It also have support for meta property, but we don't use it now. So okay. So I have declared a bunch of actions for each API, basically, to cover all API in the clients. So you have load, create, update, and delete. Okay. So now let's check our root action type. So our root action type is basically a router and our articles actions. And if we check the types here, root action will be the union type of all of the actions. So you have call history method from React Router, and also our load articles request, and the rest, like 10 more. Let's see. So now, with this setup, we should start to implement some asynchronous functions. Let's create. For that, I will be using redux-observables and RxJS. I will write some epics here in the article folder. So let's take it. So, okay. So let's start from the beginning. So here you can see I'm importing root epic. Root epic is something I need to declare. Or is it there? Okay, we have a root epic. So when working with epics, we have to provide the definition for them. Root epic, not so for each epic, I'm declaring. Normally, I would need to do it like this: import the epic from redux-observable library and provide it like input stream. So it's root action, output, also root action. Then this state, root state. I need to and services type. And this will give us so the action object has correct type, as you can see. It is union of all types because basically every action can enter this epic. Then we have state. I need to import root state from here. But my types is not working. Okay. Check why. Okay, let's fix the. So I need to delete this one. Okay, I will just copy the application epics as well. Oh yeah, this is this one. So here I have some. Here I will add another folder, which is application features. Application features is something that is running like is specific to your application, like cross-cutting concerns. So in this case, I have two epics. One is to load data on application start, and second epic is persist articles in local storage. So this is created only for the so in our mocked API we are preserving the changes. So now that we have this, I need to add, still I haven't added in the services, I need to add types for services as well. So let me copy it. Okay, I will copy all of them, basically. Okay, so here I am using the same trick. I have the in index. I am importing all of the services, different services. I have a bunch of them, like the API, local storage, logger service that I will log some errors. Toast service that will show the toast like error messages to the user. And I have types, which is basically importing this object here and taking the type of it and exporting it in the my types modules. So now I should be able to yeah, and now it seems to be working. So I could coming back to epics. Types are fixed now because I declared the missing type. And normally you would do something like this. So you declare your epic type for each epic, which is kind of not optimal. So I just extract this one and add it in the store in the types, and I declare this root epic. And now I can, in all of my epics, I will just use this type. And that's it. It works everywhere. I don't do this anymore. Here, as you can see, we have now working types. So we have the state type correctly typed and inferred, because here actually all of the epics arguments are inferred from this type. So I don't need to provide any explicit types here, because it just works. And then it also, like when working with pipes, basically arguments continue through the pipe, and their type is refined with each call. So for example, here we are filtering the action to specific one which we want to handle. So here it's load article request. And now if we declare here action, we will see that the type has changed, and it's basically the type of that particular action creator, load articles, payload action. And if I comment this, you can see that it's back to the union. So it's working really well. And also here, as you can see, I am creating a new stream from the load articles from the API client. I'm loading the articles, and load articles are returning the promise with articles. And here, when we pipe, use pipe, another pipe, and we have a map function. If I used other syntax here, like try to do this without pointers, with pointers. It's actually not action. It's actually the response. So we can see that here is also the type is refined to the articles, which is unwrapped from the promise, because pipe is actually a monad, so here we are working on the operators which are working on unwrapped values. But and also here with catch error, actually the message is any type, so we don't care about it, because error could come whatever, and we don't know what, and so we should type it explicitly. Like there is no like solution for that to infer it from some API. At least I don't know any, but it works just fine. And here I'm so maybe a little bit how that epics works if you don't know about epics. So basically it works like a pipe. It passes stream of actions that coming from Redux middleware, and we are just doing some operation on them. Here is like filtering switch map, so we are switching from action to some other value, in which case is articles, and based on that we are either emitting the new event, which is in a success case success action of load article, or the failure action. Other epics are similar, with the exception of delete articles epic, which I added the error handling. So here, what's interesting. Also, I don't know if I mentioned that this service type is using dependency injection. So I'm actually setting it up in the store. So instead of the concept is, instead of importing and adding hard dependency to your modules, like this various services, we want to inject them, and to do that we are setting up here the middlewares for the Redux. We can set it up dependencies, and it's actually the services module that I exported from the services folder, and then they will be injected for each epic. Let's go back. Which ones? Okay, so here we have IntelliSense, so we know like which kind of services are available at the time. So here I'm using the toast service, and on delete article, when there's error, when we delete article coming from the API, we will show the toast error message and then return the action, which is the failure action with the payload of the initial action. I will show you why I'm doing that. Here is basically I'm using the concept in my application. I'm using the concept of optimistic updates. It's something that whenever I do some asynchronous action in my application, I don't show the loading and wait for the result to return from network, but I just I'm just changing the state of the application, and then whenever there is an error, I will bring back the previous state. It is nice because user have like a very streamlined experience. It don't see any loading indicators, so it's much more responsive and better experience for the user. Okay, so we have this covered. So now, when we have epics ready, I think we can go. Let's close a bunch of this stuff. So now we have that setup, we have epics, and basically most of our logic, business logic of our application. So we can start implementing some views. To do that, first, what I like to do is to create a layouts folder. So it's basically a frame or a home of the application. So repeated parts that we want to, we don't want to duplicate on each view. So let's copy it. I have main layout here. It's showing some header, some icon of application, and also it will be rendering actions menu. Actions menu is actually a render prop, and it allows later in the root view to inject the actions of the specific view to basically change them from the consumer. Now that we have that, let's. I also need to copy some components. Let's create the folder components. So I also like to keep the one like main components folder, which is out of the features, and it contains like some mostly the presentational components and reusable components that I can reuse in features. So here I have like some flexbox helpers and also backlink. I will come to them later. So now let's. So now we have the layout. So we should add roots. So what I do now is this one is not this. I create also roots folder, and in roots folder I create a component that is actually composing the view of a specific root. So here I have home root. Home root is actually showing the article list and display article actions menu in the render prop for action menu of the main layout. I also have add article root, so article will show the article form, and backlink in the actions menu. Then I have view article. View article is actually showing the article. It's connected to the Redux store, and it's using the match property from the React router to get the information from the query URL parameter to load a specific article that we want. Then we have the edit article, and edit article is actually a reuse for edit article is using article form, and article form is handling both cases, which is to add article and edit article. The difference is only that I pass the article and that it will read all of the data from this. Okay, so I'm still missing the article's feature. Okay, so now I need to add state and reducer. So let's go back to features. Okay, so now let's start with reducers. So for reducer, generally I using the typesafe-action library. I'm using this approach because it's actually pretty hard and verbose to create like regular switch case reducers with all of the types annotation, which is like takes a lot of time, a lot of boilerplate to do. So I like this approach. So there's like a create reducer action, and basically what's very interesting about it, that you don't need to provide any types to it. It works using the declare module that I showed you before. Let me go back to types again and actually show you in the store. So here we can typesafe-action library allows you to extend the like internal types. So basically what I am doing here is I have the interface. So this is what I was speaking about in the beginning. So you can extend basically interface with some additional declarations. So here I'm declaring root action and I'm using the same type that is in my types. And what it does, it like enhance the API of typesafe-actions. So I don't need to provide the type anymore, and the API will have this type already. So let me show you. So this create reducer API was like that. Let's create some reducer. So basically, normally we would need to provide two generic types. One would be the root action. So whatever, I can type some action like this. Maybe whatever type. And here I need to provide, actually that's other way around. First I need to provide state. So state could be something like likes number. Okay. I forgot that this. No. Yes. And now I should provide like initial state. So I have the helper from the compiler likes whatever initial state would be 0. And now I can add handles for this action. And it will guide me, it will actually help me with all of the types. I don't need to remember them. So let's do it. Sorry. should turn it. How to turn it off? Okay. So now handle action is actually first. It's accepting the type. So as you can see, I declared that I'm using, maybe to make it better, let's declare a type here, which is normally action. You use that most often, so we will have like union type. So we have one action is without payload, second one is payload, and is type 1, type 2. And now, if I use that as a type, what you will see, it will show me these types. I can even use array to declare like both of them. So I can use one and the second one. And now I can provide the handler. And handler is also showing me exactly all of the types that I need. So here, the state. And the action. Now let's do some coding. So we have the state, likes, number, and the action, which is type. So in this case, action is the action should be
type 1 and type 2 in handler.
a second. So let me change. It's that. Okay, need to change that. Okay. Now, whenever I change this, for example, when I use type 1, for example, so action doesn't have any payload. If I use type 2, then yes, we have a payload. And as you can see, I don't need to like add any types, right? I can even delete this one and use the original my application state. So let's do that. Let's see what kind of action we have. Okay, we have a bunch. We even have React router action we could manually call. So let's say we have a load article success. So now we should have action with payload of articles. And yes, we have it. So we can like get instance and check the title, for example. Change, do whatever we want. And what's more interesting is one more thing. It's also the handle action is updating its. So imagine that you handled the type 1 already. I will just return the state. And now I want to handle another one. And check this, only type 2 is available. Like the API knows that I already handled type 1 and I don't need to handle it anymore. So imagine that you have like a long handle action like this one, right? So it helps you to know which one is already handled. You don't need to check like, okay, did I handle that action or not? So you don't need to remember that. Okay. So here, I also like this approach that you divide your reducer based on the substate. So for example, I usually don't use like nested states in my updates. I usually use like, as you can see, operate on flat values. So I operate here on Boolean and here on articles, instead like creating a reducer which has an object of is loading articles and articles. It makes like, for me, the benefit is make me easier to track like what would change, like what will change this this particular state, like which action will change that, instead of other way around when you have like action and you update several states parts. I like this approach more. Here are some regular state updates, so everything looks good. So now we have the reducer, so we can go into and try to connect some components. Maybe we can have a break now, like 10 minutes, doing something. And okay, so now we have all set up in place for Redux state, Redux actions, epics, reducers. So now we can start connecting our components to the Redux store. So let's start with article list. So how to do it? First, I will import root state from my types. Then, oh, something. Let me check what's wrong here. Reducer, sorry. Okay. Close. Okay, now it's okay. Let's open article list, and yeah. So to map state to props in connected components, I'm declaring the map state to props function as usual, and just add the root state annotation, and then the state will be properly typed and validated for all of the members that are declared there. I also like to use selectors. So here I'm using the selector to get the articles. So to declare selector, I also use root state, as you can see, and return the articles property from inside this. So selectors are really nice because if you don't use it already, I recommend it, because then you can very easily change anything inside your state. Like, you will only change the code here and not inside the components that use that. So it's much easier to do. So I declare the dispatch props, and then I usually don't repeat props interface for my React components, because like I think it's redundant and like create like a lot of noise that is not necessary. Like here I use return type to get the map state to props function return type, and also type of dispatch props. Here is empty, but I will show you in other components. And I get the props definition of this component, and I can use it in React FC interface when I'm declaring my component. And then, as you can see, I have all of the types here. whenever I want to use it. And here the connect is I'm just adding the two arguments, and it also validates and changes, like it refined the type of article list. So whenever I remove the when I would remove the connect, I can show you. Article list. Now, as you can see, article list. Okay. So the comp component doesn't have any props right now on the interface, because connect is actually removing them based on mapped state to props. So if I remove the connect, the props are back here, articles, and is loading. So it's injecting the state components and also changing the signature of return component, so it's showing the actual truth about it. So you don't need to add like some generic arguments here. It's not necessary at all. Type inference is enough. And also for dispatch props. For dispatch props, I just declare object. I don't use map dispatch to props function. I prefer the object. It works really well. And here I also can join the props declaration if I have some additional props that I want to add to the pattern that I show you here. So whenever I want to like add some own props or something like that, I can extend with this syntax, with type intersection syntax, and add some props here. So whatever. Okay. Here in dispatch props, it's also, I just mapped it to delete article method, and it's also validating it accepts article object. If I pass anything like else here, it will show an error. Or not pass parameters, it will also show the error. So it's like automatically taking the signature of our create async action definition here. It's basically taking this type from here back to here automatically. You don't need to like write any type annotation for that, and it's working here. So okay. Also, one more thing I wanted to show you is here how I get the. This is an interesting type that I wrote to get the path of the root. So basically, what I did is I declared the path object that have like functions for each root, and it can accept argument or not. Like in case of simple path, it doesn't require argument, but in case of like view article, when we need to provide the ID of the article we want to show, so we need to add this argument. So here in this type, I am basically, first let me show you how that works. So I get path, and here I have an auto-completion which root I want. So for example, home, and if I do that, I will get a string, and yeah, it's fine. It doesn't show error. But when I change it for something that requires parameter, for example, edit article, it will complain that something's wrong. Is expected to argument. It actually will check for this parameter. So I need to add it something. So it actually changes the how this function behave based on the first parameter. If I change it again to home, showing the error again. So how that works is it uses this spread syntax, and also the helper parameters helper type from standard library in TypeScript. So I basically take the based on the first argument, which is the troot type, which extends these keys. Then I take from the type pathmap, which is type of that. I take the value, so this, and get the parameters, which is the function signature, and then take parameters from the from this function, and just pass it here as a second argument. So whenever I would add here another one, like number, it will also change. So now I will need to add like 3 parameters instead. So this is like something that maybe you might find helpful in your projects as some utility functions. So how I use that in my router, let me show you. So I basically use it like that. I changed it. It is broken now because I changed this. Okay, so I need to add number. And as you can see here, I just use getPath for the roots, and I get this for home, for article. Here I add the article ID template for the React router, and then the same thing. I use the same function to actually to navigate in the application, but instead of the string, I will use the ID. Where it is? Backlink. Oh. Oh, 1 second. Do it like this. Yeah, like this. No, this one. This one. Okay. So here I will add an article ID to link to some specific route. So yeah, I think that's all I wanted to share. So now you can ask questions if you have any. Thank you.